Hello, everyone. My name is Gavin. Welcome back to my MCAT series where I pretty much just track my progression throughout taking the MCAT. This is the second episode of the series. Today, I did another UWorld passage focusing on the biology and biochemistry sections. Overall, I feel like I can't really say if I did good or bad, but I definitely made mistakes, but that is okay because I'm making them early on. But thank you guys for joining back with me. To preface, I'm not a doctor, so this is not a substitution to your MCAT studying, nor am I trying to come off as I'm teaching something. I'm simply practicing the Feynman technique of just talking it out. So thank you guys for joining here. I will say that there were a few topics today that I had a clear content gap and ones that I just wanted a good refresher on. As someone that hasn't taken biochemistry prior to beginning the MCAT prep, I feel like biochemistry is just something that I've been having to learn from a fresh start the whole time. But I'm telling you right now, so we're up. But let's get going. I'm going to share my screen real quick. All right. Okay, so these are the following topics that I pretty much wanted to review on. Pretty short, quick, but the first one was achiral amino acids, which there's only one. It is glycine. That is because the alpha carbon only has two hydrogens bonded to it, meaning that it is not asymmetric with four different binding groups to it. So it is achiral. And this affects many things, good and bad. But one thing that I was not aware of was how it affects plain polarized light. The other chiral amino acids are able to pretty much change, in a sense, the plane of polarized light. If you rotate clockwise, it is a positive change. And if you rotate counterclockwise, then it is negative. Kind of just simple way to put it. But one thing about achiral glycine amino acid is that it does not rotate plane polarized light due to the lack of its asymmetric alpha carbon. So that was one thing that I pretty much just learned today. So that was pretty cool. The next topic was on topic of glycogen, just a good refresher. Glycogen is composed of bonded glucose monomers, molecules. The main thing is that they are binded um, in linear segments linked via alpha 1 4 linkages, and also they are branched at alpha 1 6 linkages, which pretty much means that the branched right here, this is a fun little document I found. Shout out to Dr. Baria Ali Maki. Shout out to you. Thank you for posting this online. But but as you see, the glycosidic bond for branching glucose monomers is a 1,6, which means that if I'm looking at a monosaccharide right here, it is the 1, 2, 3, 4, 5, 6 carbon bonded to the one carbon right here, 1,6. And then the 1, 4 is in correspondence to these linear segments right here. So if I do 1, 2, 3, 4, that's bonded to the one carbon right there. And one thing that I was not aware of with glycogen is its debranching process and the enzymes that are a part of that. The first one is transferase. For simple way to put it, there might be a learner name. Okay, transferase. It's going to transfer the, in this example here, the three out of the four pretty much to the end there. So it's just going to transfer it to the end, right? To continue the linear segment. And then the second step is performed by the enzyme glucosidase, and it's going to cleave that single monomer right here, to where it's pretty much just free. Um, and the reason I got this wrong was I was just asked um, which compound is not involved in debranching, and silly me, I chose a two sits bonded um, glycogen branch for some reason. I don't know why, but missed that there. But I feel like I have a good refresher of those simple topics so far. Next one is just the net ATP from glycolysis. I was hammered with glycolysis um, and all the sort and all the various processes of breaking down uh, glycogen to glucose from glycogenolysis and then gluconeogenesis, just forming glucose, hammered with those questions today on UWorld. So yeah, they got me. But one thing to note is that the net ATP from glycolysis is 2 ATP because 2 ATP is consumed and then 4 ATP are produced, which means that there's a net profit of 2 ATP from glycolysis. And which enzymes require this? It's hexokinase and PFK1 in step 1 and step 3. If you see from this picture here, shout out to microbenotes.com. Much love. But as you can see here, that hexokinase in step one uses ATP, and so does phosphofructokinase, and step three here. Um, One thing to note as well is that step one and three are irreversible steps, so they cannot go back, as you can see from the single arrow here. Another thing to note is that steps 7 and 10 produce 2 ATP each, is where you get the ATP from. The enzyme that does this is phosphoglycerate kinase. That says right here. And then also right here is the pyruvate kinase. A lot of kinases in this, but also um, remember that aldolase also has a step here. I'm blanking on that one too. So, refresher for that for sure. And then on the topic of glycogen in general, I was really unaware of the different systems in the body as far as glycogen storage goes, in comparison with muscles and the liver. As far as glycogen storage goes, the muscle lacks significant levels of GCP or glucose 6 phosphate compared to the liver. Thus, the liver is much more efficient at regulating glucose levels because it is able to promote these processes of gluconeogenesis and glycogenolysis much better, or much, yeah, pretty much more efficiently, much better than muscle. So that was one thing that I was pretty much having to tell myself there. Um, Next topic, citric acid cycle. I reviewed this one time and then stopped, so it was clear why I need to review this again. The main thing is that the citric acid cycle produces metabolites that are directly used into the ETC, the electron transport chain. It produces these metabolites that are involved in the complexes in the beginning. I think it's the first and second one, maybe, third one as well, perchance. But these four enzymes are right here. I have a nice little picture here. Again, shout out to Microbe Notes. Much love for showing this picture. But one thing to note here is that this kinase or this enzyme, isocitrate dehydrogenase, produces NADH directly used into the electron transport chain. Alpha keto glutarate dehydrogenase also produces NADH for the ETC. Um, Same thing with succinate dehydrogenase produces FADH2. It's the only enzyme that produces FADH2 in the Krebs cycle, citric acid cycle. And the last one is malate dehydrogenase, which also produces another NADH. And these four enzymes here, I was pretty much just asked which enzymes produce metabolites on UWorld, and I missed it because I don't know. But one thing to know is that just like I said, the succinate enzyme is the only one that will produce FADH2. I think it's via reduction. Yes. So one thing to remember there, and also just good thing to remember in general that this whole cycle just reduces, right? It just reduces NAD plus to NADH. Same thing here, same thing here, same thing here, at the cost of oxidizing these substrates throughout the cycle because it's a oxido reduction process. So it's a oxidation reduction process that is a cycle. It is continuous. Which shout out to the body for knowing that. So that's cool. Another thing about the liver I don't know is that it primarily regulates glucose levels during fasting. And of course, I knew that the liver regulates blood glucose anyways, but during fasting, it will up regulate pyruvate carboxylase, which in return will um, promote production of oxaloacetate, and then with that will promote gluconeogenesis. So when you're fasting, you're obviously not consuming a lot of sugars, a lot of calories in general. So your body has to be able to form glucose for energy production on its own. So the liver is what regulates that through a process. Not sure on the exacts, but yeah. Miss a question on that too. All of these I miss a question on. So there you go. Except for that one. But and now, whatever. Next point here is I thought it was just worthwhile for me. I'm trying to zoom in. Yep. I thought it was just worthwhile to really just know these compounds right here that are involved. I had a weird question from UWorld, which I actually guessed correctly, but it was which of these processes is not involved in something. I kind of forgot what the question was, but I don't think I'm legally allowed to share that anyways. Whatever. And it was pyruvate and citrate and oxaloacetate. To be honest, I forgot what the question was, but I thought it was just worthwhile to just be able to recall these compounds so that if you are asked a question about like which of these compounds is the product of glycolysis and it gives you just the compounds, you know that the pyruvate one, that's for every glucose molecule, uh, or yeah, glycogen molecule, that two pyruvates are the product, um, and it'll help you there. Last point is pretty much just talking about the mainly in the reproductive system process, but really honing in on before and after fertilization in females, pretty much is what happens to the hormonal levels in the body. And uh, my question pretty much was like during fertilization around week 8, which is a pretty standard mark for these relationships that you see here. I got this question correct, but I thought it was just good because I kind of forgot it for a second. But during fertilization around week 8, you're going to experience increased levels of estrogen and progesterone and decreased levels of FSH and LH. Those are hormones that pretty much drive phases of the menstrual cycle and also um, follicle stimulating things to prevent or promote follicle development. And the reason that these are upregulated is because of fertilization, and then these are down regulated in order to prevent the new development of another follicle. I hope I'm pronouncing that right. But this isn't the same when there's no fertilization. We see that before fertilization, kind of jot down here that FSH and LH are increased to pretty much trigger the oocyte egg release, and then also like throughout the menstrual cycle wave, there's a peak, and then it's like a slow rise of estrogen and progesterone to pretty much drive the next cycle into release another egg. So I thought that it was interesting that these relationships are very honed on a lot in the biology section. I found these to be in a lot of discrete questions so far instead of passage based, but will not take my word for set in stone there. But yeah, guys, that's pretty much it. I'm gonna stop sitting on my stream. Yeah, guys, again, getting through it. It is a process and it's a long one and it's a tiring one, but I will say that it's been very neat to learn the amount that I have learned so far, and also just appreciate the amount of knowledge that we know about the body. And I'm not going to give a motivational speech, but I just want to say thank you guys for watching. Tomorrow I will be doing the site-search passage-based questions and street questions as well, and continuing to do a cars passage. But guys, I want to say thank you for watching. And good luck to whatever y'all are doing right now. So, God bless.